So now let's look at more examples here I'm going to give you and try to determine what is the total degree of unsaturation in this molecule. This is called a cyclopentene. Cyclo because it's ring form incorporating 5 carbon. Cyclopentene. Alkene because it has got a double bond of carbons. So the degree will be 2 because it comes from 1 ring and 1 pi bond. Remember a pi bond? It is the second covalent bond between any 2 atoms. The first bond is a sigma bond and the second bond here is a pi bond. So 1 plus 1 you get 2, so 2 degrees. And with that we can determine the formula very quickly. C5H8. To verify it, 1, 2, 3, 4, 5, 6, 7, 8. Indeed, it is C5H8. So how did I take a short period of time to determine the structure? I tell myself that there are 5 carbon. So I just imagine, suppose it is alkane with 5 carbon. It will be a C5H12. Remember, 2n plus 2. So I know that there are 2 degrees, first outlook, and I subtract 2 times 2 hydrogen, and I get 8. So for every degree of unsaturation, I subtract off 2 hydrogen from what I should get theoretically from the alkane formula. Next example. I see a benzene here, but let's make it more interesting. Okay, what are the functional group present? Let's revise. An A ring, a benzene ring, double bond, this is the alkene, and carbon-carbon triple bond, that's the alkyne. So, take some time and see what is the total degree of unsaturation in this molecule. This has 1 ring, enclosed, and how many pi bonds? 1, 2, 3, 4, 5, 6. 6 pi bonds. So the sum of these give you 7, and hence 7 degrees of unsaturation. So the formula will be as such: 6 carbon, 7, 8, 9, 10, 11. Watch it. C11, H, how many? Supposed to have 24. So quickly I subtract 14. I get 10. C11H10. Let's do verification. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, indeed, it all matches up. Let's do one last one here, just for your practice. That's a chlorine. That's a bromine. Double bond. Okay. Again, let's recognize what are the functional groups. Halogen alkane, alkene, and this is a ketone. Carbon, CO double bond, carbon. You see, it's a ketone. So how many degrees are there? 1 and 2 rings. Pi bonds, 1 and 2. Pi bond could occur between a carbon and another atom besides carbon. So we have 2 pi bonds. So the sum gives us 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 carbon atoms. Alright. So how many hydrogens are there supposed to be? 22 minus 8 give us 14. But I'm not going to put 14 here. I'm going to put 12. Later on, you'll see why. Okay? We also have oxygen. One of them, chlorine, and then bromine. So this is the chemical formula. Let's verify the number of hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Where's the 12th one? Ah, over here. The 12th one. Okay, so indeed there are 12 hydrogen. So what happened just now? Why did I get 14 and yet automatically I subtract another 2 to get 12? Because here you notice I have halogens, chlorine and bromine. And halogens behave the same way as a hydrogen atom. Because halogens come from group 7 of the periodic table, they all form one bond, just a single bond. So I could replace them with hydrogen and it is similar. So in this case, we subtract another 2 to get 12. Which means to say that if I look at this molecule, a bromopropane, this has 0 degree of unsaturation because the chemical formula is just C3H7Br.